Hi, the question is, a fusion reaction is given by this uranium 92-236 and product we can see Jn 54-140 plus this is the Sr. This is the Sr and this is what 3894 plus X and plus Y, where X and Y two particles. Consider this to be raised. Kinetic energy of the products are denoted by this. Kinetic energy of Jn, kinetic energy of Sr, kinetic energy of X is given, that is equal to 2 mega electron volt, and the kinetic energy of Y is given, that is 2 mega electron volt respectively. Let the binding energy per nucleus of this is given. All atom is given uranium, and X is given and Sr is given, that is equal to 7.5 mega electron volt, 8.4 mega electron volt, and it is given that 8.5 mega electron volt, clear, respectively. Consider the different conservation laws, clear. The correct options are, so we have to choose the correct option, we can see, clear. Now we can find this X and Y, we can find this is the unknown particles. So how we can find this unknown particles? We have to apply the conservation of mass and the conservation of this atomic number and conservation of this from protons, we can write. So from conservation of mass we can write this is equal to 236 should be equal to, means we can see that in the reactant side there is a 236 is equal to, we can write 140, and plus we can write 94, and plus we can write this is what mass number of this X is what X1 we can write, and mass number of this Y is what Y1 we can write, clear. So from here we can see that 236 is equal to, this is the 140 and plus 94, this is equal to 234, and plus we can write X1 and plus Y1 we can write. So X1 plus Y1 is equal to, we can write from here, this is equal to 236 and minus 234. So this is equal to what, 2 we can see. So this is what sum of the mass number. Now from here we can see that from this atomic number conservation, so we can write from here 92 is equal to, we can write this is equal to 54, and plus we can write this is what 38, and plus we can write X particle has this X1 and plus Y2, X2 and Y2 we can write, clear. Now from here we can get this X2 and plus Y2 is equal to what, 92 and minus 92, and this is equal to what, 0 we can see, means X2 and plus this Y2 is equal to what, this is equal to 0. So X2 and Y2 is equal to 0, clear. Now we can see that sum of the mass number of X and Y is equal to 2, and sum of this atomic number is equal to 0. It means we can write from here this X2 is equal to 0 and Y2 is equal to 0. It means we can see that particle is what, neutron. Neutron, we can see that this atomic number is 0 and the mass number is what, 1 we can see, and plus we can write this is the neutron, 0 and 1. So we can see that this is the neutron, means X is equal to, we can write X is equal to N, and this is what, X and Y. So we can see that X is equal to N and the Y is equal to what, N, neutron. So A option we can see that X is equal to N and the Y is equal to N, and we can see D option also, X is equal to N and Y equal to N. So A and D may be a correct option. Now we have to choose which one is the correct, A or D, clear. Now we have to check this kinetic energy, we have to check, clear. Now from we have to find the kinetic energy, so we can find the change in energy, we can find. So del E is equal to, we can write this is equal to 236 number of nucleons, we can see that this is a 236, and the binding energy is given of this uranium, and this is equal to, we can see from here, this is equal to 7.5. So we have to multiply by this 7.5, we can write, clear, minus we can write 140, minus we can write 140, we can see this Xe atom, and this is equal to 140, and 140 into, we can write, this is the 8.4. So 8.4 we can write, clear? 8.4, and minus, we can write, this is the 94 into, we can write, this is the 94, and we can see from here this is the 8.5 mega electron volt. So we can multiply by this, minus 8.5 we can write, and minus we can write this binding energy of this 2 neutron, and this is equal to, it is given 2 mega electron volt. So this is equal to what? 2 and 2, 4 mega electron volt. So after solving this, we will get this binding energy, change in energy we will get, and this is equal to 215. Now this is the change in energy, and this is what? Mega electron volt, clear? Now we can see that sum of the energy of this K and XE, sorry, SR and XE should be what? 215. Now sum of this, we can see that here sum of this SR, kinetic energy of this SR is what? 129 in the A option we can see, and kinetic energy of this XE we can see that is equal to 86. So sum of these two is what? 215. And the D option we can also see that this is the 215 mega electron volt, and in this we can also see that 215 mega electron volt. Now we have to see which one is the correct. So here we can see that the kinetic energy of this SR is what? 129. So we know that this kinetic energy is equal to, we have to use this concept, kinetic energy is equal to P square and divide by what? 2m, clear? Now from here we can see that for this, here from here we can see that this kinetic energy is the inversely proportional to this mass, clear? For this, for a given momentum, clear? This P is what? Momentum. So for given momentum, we can see from here this kinetic energy inversely proportional to mass, means we can see that this mass number of SR is less than the kinetic, this mass number of this XE. It means we can see that kinetic energy of the SR is the greater than the kinetic energy of XE. So in the A option we can see that kinetic energy of this SR is 129, and the kinetic energy of XE is what? We can see 86. But D option we can see that kinetic energy of this SR is 86 mega electron volt, and kinetic energy of X is 129 mega electron volt. So A is the right option for this question, clear? Hope this answered your question. Thank you.
Hello everyone, let us start with our question. In this question, what is given that in the option given below, the E denotes the rest mass energy of a nucleus and N is a neutron. We need to find which option is the correct option. Now what is given? So this is the rest mass energy of uranium. It is greater than, yes, this rest mass energy of this iodine is plus rest mass energy of yttrium plus 2 times rest mass energy of neutron. So this is how this expression has been given. So this is basically what? So uranium is a this heavy nuclei, okay, and these are compared to the uranium, these are smaller nuclei. So they are, this is a, basically we can say that this is a fission process, okay, because a heavier nuclei is breaking down into a smaller nuclei, okay. This is a fission process. So this is converted into this, okay. Now there would be, since it is converted into a fission process, so there would be an energy, okay. Now we know that by Einstein relation, we say that the energy which is generated, this would be equals to delta m c square, where delta m is what? It is basically the this mass defect between the reactant and the product, okay. Now this would not be zero, okay. So therefore the higher this mass defect, the greater would be the energy, okay. So how can we see this? Now uranium, if we see, uranium would be having a greater rest mass energy as compared to its this constituent. Why? Because this would be basically unstable. We can say that because uranium, it is disintegrating, or we can say that it is converted into this I and Y. So we can say that this would be unstable, okay. And here the product would be more stable. That is why they are converted. Now, if it is unstable, that means it would be having a greater energy as compared to its product. Now, if we check our first option, it is given that uranium, this energy of the rest mass energy of uranium is greater than rest mass energy of iodine plus yttrium plus 2 times neutron. Now this would be the correct statement, okay. According to the fusion reaction, we already know that the product would be having a greater energy. That is why we are getting some amount of energy in the this would be released. So this would be the correct option. Now in the second option, it is saying that it is less than. No, it won't be less than. Why? Because how it will be getting energy? Okay, if it is less than, so because these are getting the energy from the reactant itself. Okay, so if the product cannot have a greater energy as compared to this. Okay, now in the C option, it is also it is already given. Basically, this is an extension of the same option, but with different element. So even though if you are changing the element, then also this food should be greater than, U should be greater than this rest mass energy should of the uranium should be greater than the product, because they would be more stable. So more stable means less energy. Now in the C case, it is given that these are equal to. No, it won't be equals to, because there would be some amount of energy that would be released. So we cannot say that it is exactly equals to the rest mass energy of barium plus krypton. Okay, so the only correct option is our A option. Hope you understood this solution. Thank you.